Alright guys, this video is on logarithms. What is a logarithm, you ask? Well, a logarithm, or log for short, is the exact opposite of an exponential. And they are written in the form of log base A of B equals C. Now, when you see this word log, that means you're dealing with a logarithm. This A here is your base number. The B is your answer to your exponential, and this is your exponent. Alright, basically what that means is if this was written as an exponential, it would be A raised to C equals B. Alright, that's how they convert back and forth. An easy way I tell people to remember this is remember a spiral. Okay, start at your base, spiral up to your C value, and then come back down to your B. A raised to C equals B. Now, to go back, all you have to do is remember the same spiral. You start with A, that's your base, spiral over to the B, and then come back and end up at the C. Alright, let's look at an example with some real numbers here. The log base 2 of 8. Okay, so what is the log base 2 of 8? So basically what this is asking is 2 to what power equals 8? That's basically what they're asking. So 2 raised to what power is 8? Well, you should know that x would be 3 because 2 cubed equals 8. So the correct answer for over here would be log base 2 of 8 would equal 3. Alright, the log base A of 1 equals 0. This will always be the log base A, doesn't matter what your base is, log base A of 1 will give you 0. Why, you might ask? And how do I know this? Well, think about it. Anything raised to the 0 power, because if you do your spiral, anything raised to the 0 power is 1. So that's how we know that the log base A of 1 will always give us 0. Second property, log base A of A equals 1. How do we know that? Well, A raised to the first power is just A. Okay? Anything raised to the first power is just what you started with. Nothing's going to change. Now, log base A of A raised to the x is going to equal x. Okay? And this is called your cancel rule. Alright, that's called your cancel rule. Alright. Now, next one is log base A of 0 equals negative infinity. Why does this equal negative infinity? Well, because A raised to the negative infinity equals 1 over A to infinity, which just equals 1 over infinity, which equals 0. Because remember, 1 divided by infinity is 0. And A to the infinity is a big number. So, as the bottom gets bigger and bigger and bigger and bigger and bigger, this gets closer and closer to 0. So 1 over infinity is 0. So these are 4 common log properties that you're going to need to remember. So make sure you write these down and commit these to memory because you're going to need to know these. Alright, so make sure you write these down and commit them to memory. Alright, now let's move on to some graphs. Right? If you remember from the previous video, this here is your exponential graph. We'll call it y equals 2 raised to the x. Okay? It's your exponential graph. If you remember, that always goes, exponentials always go through the point 0, 1. All right? They will always go through the point 0, 1. Now, log graphs, okay, this here is your log base 2 of x. All right? Your log graph will always go through the point 1, comma, 0. Okay? It will always go through the point 1, comma, 0. Because if you think about it, these are reciprocals of each other. All right? They will be reflected across the line y equals x. All right? Reflected across the line y equals x. All right? They are inverses of each other, if you want to remember it that way, and that's actually true. They are inverses of each other. Okay? So, just remember that the graph of a log, unless it's been shifted, which, as you found out with the work we did today in class on exponentials, they can be shifted, but the base graph of a log will always go through the point 1, comma, 0. Will always, always, always go through the point 1, comma, 0. All right? Doesn't matter what the base is. Doesn't matter what the base is. Always go through here. Just like exponentials will always go through the point 0, comma, 1. All right? Now, natural logs. If you remember the natural base of e, if you have a log with the natural base of e, all right, it has a special name. All right? Log base e of x has a special name. It is called the natural log of x. Now, the natural log will always have a base of e. All right? Natural log will always have a base of e. So 99% of the time when you see a natural log written, it will not have a base. All right? It'll look just like this. It will not have a base, because the only way to get a natural log is to have a base of e. You cannot have a natural log with a base of anything other than e. All right? Now, with the regular log, the common base is 10. So if you see a regular log written without a base, okay, it's an understood 10. All right? The base will be an understood 10. Just like here, it's an understood e because it's a natural log. Natural log is ln, not nl, like it sounds like it should be. It is ln, natural log. All right, some properties of natural logs are as follows. Natural log of 1 equals 0, because e raised to the 0 equals 1. Natural log of e equals 1, because e raised to the first power is e. And then the natural log of e to the x equals x. So as you can see, these properties for natural logs are the same properties that you see for regular logs. Okay? They're the same properties that regular logs have. Alright? So that's pretty much it for your kind of like an introduction video to logarithms. We will have some problems on this in class tomorrow. They shouldn't be that difficult to solve for you, because like I said, this is just kind of like an intro video to logs, because you might not have seen them before now. So see you tomorrow in class. There's no ticket in the door. Just be ready to tackle some log problems. All right? See you tomorrow. Alright, this video is going to be on 4 big log rules that you're going to need to remember. So make sure you write these down in your notes and remember how to use them. The first rule we're going to go over is the addition rule for logs, which says if you have log base A of B plus log base A of C, that equals the log base A of B times C. All right. So when you add, when you add them and they have the same base, you can multiply together what you're taking the log of, and it'll be the same as log base A B times C. For example, let's simplify log base 2 of 2 plus log base 2 of 8. All right. So if we're following our steps here, we're going to have log base 2 of 2 times 8, which is the same thing as the log base 2 of 16, which of course equals 4. Alright, and of course equals 4. Alright, now there's a few rules for this rule. Alright, there's a few rules for this rule. Number 1, must be the same base. Alright, remember your base is that little number. It's like that subscript number. Alright, they must be the same base. So if you had something like the log base 2 of A plus the log base 3 of B, well, you can't use this rule. Alright, you can't add those together using this rule because they have different bases. Alright, they have to have the same base in order to use this rule. Alright, so for this one, it's just tough luck because you can't use it. Alright, also, second rule for our addition rule. Logs can't have coefficients. Forgot my E. Alright, logs can't have coefficients. So for example, get that out of the way. So for example, you can't do 2 times the log base 2 of 2 plus 3 times the log base 2 of 4. Alright, that's another tough luck. You can't use the rule. They can't have coefficients. Alright, so, little review. Log base A of B plus the log base A of C equals the log base A of B times C. So the log base 2 of 2 plus the log base 2 of 8 equals the log base 2 of 2 times 8, which is log base 2 of 16, which gives you 4. Remember, they must have the same base, and they can't have coefficients. Alright, these would be your coefficients if you're not sure. Alright, they can't have coefficients. Alright, second rule I want to look at is the subtraction rule. Alright, so log base A of B minus the log base A of C equals the log base A of B over C. Alright, when you subtract logs, when you combine them into division. And it's always the first one, that's supposed to be an arrow, it's always the first one over the last one. Alright, that's why this is B over C. Log base A of B minus the log base A of C is the log base A of B divided by C. Alright, so if we go down here to this example, let's simplify the log base 3 of 18. It's supposed to be minus the log base 3 of 2. Alright, so following our rule, it's going to be the log base 3 of 18 divided by 2, which is the log base 3 of 9, which is of course 2 because 3 squared is 9. Just remember your spiral that I told you about. All right. Now, the same rules apply to this. Okay. So the same rules as addition. All right. So they have to have the same base and no coefficients. All right. Same base and no coefficients. It's the log of the first one divided by, it's the log base 3 of the first number divided by the second number. Log base 3, 18 over 2. All right. Let's look at our third rule. Our third rule is our power rule. So in this case, when you have a coefficient in front of your log, so c times log base a of b equals that coefficient can come around and be the exponent on your b. So log base a of b raised to c. All right. Now this rule works both ways. You can use it to take your exponent and bring it up if you need to and get it out of the front. So then you could use the addition or the subtraction rule. Or you can use it to put your exponent down in the front if you need to for some reason, which a reason we'll go over later. All right. So you can either pull it up or bring it down. All right. So let's simplify this. 2 times the log base 3 of x plus 3 times the log base 3 of y. So before, with addition rule, we can't do this. All right. But if we apply the power rule, those exponents will lift up, and it'll be the log base 3 of x squared, because the 2 will become the exponent on the x, plus 3 log base, log base 3 of y cubed. That 3 will come up and be the exponent on y. All right, so now we have no coefficients. We have the same base, and since this is addition, it is simply log base 3 of x squared y cubed. All right, so we actually used two different rules to simplify this. First, we had to use power rule to lift up or pull up our coefficient and make it an exponent on both log terms. After that, we can use the addition rule to simplify it. One, and this is usually the most confusing one, but it's not that bad. To me, it's not confusing at all. All right, if you have the log base a of b, all right, the log base a of b, if a is not either 10 or e, which in this case, if it was e, this would be a natural log. But if it's not 10 or e, if c is some other number, all right, if a is some other number, what you're going to do is you're going to do the log base c of b, log base c of b, divided by the log base c of a. The way I tell people to remember this is draw a little fraction bar between these two. Okay, draw a little fraction bar. So it's going to be b over a. Okay, and if you notice, it's b over a. Now what you want to do is you want to choose your c, your base, as either 10 or e. All right, because both of these, now if you're using the Inspire, you can change the base, but most calculators, you can't change the base of your log. So you either have to leave it as 10 or e in your calculator. You can't change it. But say this is 13, or if you look in our case here, 7, all right, you can't, in a normal calculator, you can't do this. You can't change the base to 7. You can in the Inspire that we use in class, but you can't like on a TI-84 or something like that. All right. So what we're going to have to do is we're going to have to make this, you can either go log base 10, which is what's in your calculator, of 11, all right, because this is our b value, divided by the log base 7 of 11, all right, or Remember how I said either 10 or e? If you make it 10, I'm sorry, I made a mistake right there. I don't know why I wrote that like that. Alright, it would be log base 10 of 7. Sorry about that. Alright, so here we changed our base to 10, but if you changed it to e, this would also give you the natural log base e, I'm not going to write it, of 11 divided by the natural log of 7. Both of these are going to give you the same answer. Alright, so now you can take the log base 10 of 11, or the natural log of 11, alright, and get 2.398 over log base 10 of 7, or natural log of 7, 1.946, which in turn will give you 1.23. Alright, so your change of base formula, it's the log, and then either pick 10 or e. If you pick e, you're going to have a natural log. So you're going to have log base 10, or e, of b, which in our example here is 11. So log base 10 of 11 over log base 10 of your previous base. Okay, the base that's actually in your original problem here. Alright, log base 10 of 7. Like I said, you can kind of draw a little fraction bar in there. So it's log 10, the base 10 of 11 divided by log base 10 of 7, or natural log 11 over natural log of 7. Both ways will give you the same answer. All right.